So, reason why carbon is the center of organic chemistry. So we said it's because of its tetravalent nature, because that's the valency of four. So you may have the only carbon that has a valency of four. We have some other elements in the same group as carbon that have a valency of four. Yeah, you are right. It's not only carbon that has a valency of four, but there are other properties of carbon that made it stand out among the other elements in its group. And leads us to the second reason, which is catenation. Catenation, that's ability of carbon to form straight chain, branch chain, and also restructure. Carbon carbon has a lot of compounds, is able to form a lot of compounds because it can form straight chain. That is, we can arrange carbon atoms in different ways. We can arrange like along a line, which is straight chain. We can arrange like having breaks at different points, something like this. That is branch chain. Then you can arrange carbon atoms in such a way that you have a closed structure. You have a closed figure like this. So that is carbon. So carbon can do that. So ability of carbon to form straight chain, to form branch chain, and even wave structure is catenation. And it's only carbon that has this property of catenation. So which is why is the center of organic compound. So with this property of catenation, it can form millions of compounds. Then the third reason is also because of the ability of carbon to form multiple bonds. Some elements in the periodic table, they can form some certain number of bonds. For example, oxygen forms double bond, nitrogen forms triple bond, fluorine and other halogens, they form single bond. But for carbon, carbon can form single bond with itself and with some other elements as well. Carbon can form double bond, it can form triple bond. So carbon has the property of, has the ability to form a single bond. You can have carbon, that is, you can have carbon single bond like this. You can have carbon double bond, and you have carbon triple bond. So carbon has the ability to form this type of compounds. It has the ability to form different bonds. Then also the ease at which carbon combines with some other elements like oxygen, hydrogen, halogens, nitrogen, which are also some of the elements that will be considered in organic chemistry. So those are reasons why carbon serves as a center of organic compounds. Now we come to homologous series. In our previous slide, we said that carbon form millions of compounds, and because of some of its properties, catenation, tetravalent nature, and its ability to form single, double, triple bonds. Now, because we have millions of organic compounds, studying each of the compound will be somehow like it may take a lot of time. We have to study each of the compound. So instead, we put this compound into family. So the family to which an organic compound belongs is what we call the homologous series. The family to which an organic compound belongs is what you call the homologous series. So we put some organic compounds into a group, a family, just because of some certain properties that they have. And each family is called the homologous series, and that's what we're going to consider here. So what's homologous series? So homologous series is a family of organic compounds. Yes, a family of organic compounds. So homologous series is a family of organic compounds that follows a regular structural pattern. So there's a pattern, a regular structural pattern, the compounds they follow, in which the successive members that follow each other, they differ by a CH2 group or a molecular mass of 14. So family of organic compounds, homologous series. Then there's a pattern. Look at their structure, there is a pattern they follow. And that pattern is what leads to the general molecular formula. which we are going to look at later, in which successive members that follow each other, they differ by CH2. Like if I know the first member, the next member will be obtained by adding a carbon and 2 hydrogen atoms to the previous member. Take for example, if I have a member that is CH4, for example, if one of the members of the family is CH4, then the next member will be by adding 1 carbon atom, and that will be what? C2. So I have 2 carbon atoms now, then adding 2 hydrogen atoms, and that will make what? H6. So successive members that follow each other in the family, there's actually a difference of CH2 between them, or a molecular mass of 14. Then we look at the characteristics of homologous series. We have different homologous series, which we are going to look at in the next slide. What are the characteristics of homologous series? Number one, they have the same general molecular formula. That's a general molecular formula. Take note, I didn't say the same molecular formula. The molecular formula is specific to each compound. Although we have some compounds that have the same molecular formula, which we are going to talk about later. But any compound that belongs to homologous series, compounds that belong to the same homologous series, is the same general molecular formula that they have. We look at how the general molecular formula looks like. Then they have the same functional group. Same functional group. So what is functional group? We'll look at that later. They have similar chemical properties. Like they undergo similar chemical reactions. Then they have slight difference in their physical properties. A slight difference in their physical properties as the number of carbon atoms increases, so their physical properties differ. Then they have similar method of preparation. We prepare them almost the same way. Then the successive member, which has already been said in the definition, the successive members, they differ by CH2 group. So these are the characteristics of compounds that belong to the same homologous series or to the same family in organic chemistry. And what's functional group? A functional group is an atom. An atom is an atom, or it could be a group of atoms, or it could be a bond that is common to a homologous series and which determines the chemical properties, the main chemical properties of that series. Homologous series is an atom. For example, here I give, for example, for a homologous series that we call the ether, their functional group is O. So that's an atom. But that's for the ether. A homologous series that we call the ether. Then it could be a group of atoms, just like the hydroxy. So hydroxy, they identify by the OH. So when you see a compound that has the OH together like this, is an alkanol. Then it could be a bond. So in this case, for the alkene, we use double bond to identify them. So alkene, alkanols, they are just two of the homologous series that we have. So an atom, a group of atoms, a bond that we use to identify the homologous series or the family an organic compound belongs is what you call the functional group. And the functional group is what determines the kind of reactions the substance we undergo. So the organic compounds are identified by the functional group. Now we look at the homologous series of some compounds. The homologous series of some selected family and their general molecular formula and the functional group. So we have the first one, the alkane. The functional group of the alkane is CnH2n plus 2. So to take note, the N there, anywhere we see N, is the N there is represents the number of carbon atoms that is present. So number of carbon atoms that is present. So for the alkane, we have CnH2n plus 2. They do not have functional group. We have the alkane, CnH2n, That's carbon-carbon. The general molecular formula is CnH2n. Then their functional group is carbon-carbon double bond. We have the alkynes, CnH2n minus 2. The functional group is carbon-carbon triple bond. We have the alkanals, CnH2n plus 1 OH. The functional group is the OH that we have there. So the OH is a functional group. Then the alkanoic acids, CnH2n plus 1 COOH. And that is COOH is a functional group. Then the alkanals, CnH2n plus 1 CHO. The functional group is CHO. So we have other homologous series which will be considered later. You take note of something here. We use R. What does R mean? R refers to the alkyl family. The R there refers to the alkyl family, and they are represented by the formula CN H2n plus 1. The alkyl family, they have one hydrogen atom less than the alkane. So they have one hydrogen atom less than the alkane. So let's see how do we name organic compounds. What are the rules guiding naming of organic compounds? So in naming organic compound, firstly, you must know the number of carbon atoms that is present. So we have prefixes for naming the number of carbon atoms that is present in an organic compound. So when you have one carbon atom, we say met, METH. So for an organic compound with one carbon atom, we use met. 2 carbon atoms, eth. 3 carbon atoms, prop. 4 carbon atoms, but. 5 carbon atoms, pent. 6 carbon atoms, x. 7 carbon atoms, ept. 8 carbon atoms, oct. 9 carbon atoms, non. 10 carbon atoms, dec. So now to write the name of an organic compound, we join the prefix which represents the number of carbon atoms with the ending of the homologous series. How do that? What I'm saying is the name is simply the prefix that represents the number of carbon atoms and the ending of the family name. So let's take an example. For example, the alkane. The ending of the family name of the alkane is ANE. So if we have an alkane that has 6 carbon atoms, then what will be the name? 6 here means what? 6 carbon atom is X. So that will be X. Then you join it with the ANE. That will become what? Hexane. That will become hexane. So hexane is an organic compound with 6 carbon atoms and which belongs to the alkane family. So the name will be hexane. I believe we get that. So we can try more on that. Let's see some of the alkane family. So we know that for the alkane family, the general molecular formula is CnH2n plus 2. Where N represents the number of carbon atoms that we have. Then let's start with it. If we have N to be 1, so substitute to the formula, we have CH4. So and that is methane. Remember, one carbon atom is met. Then because an alkane family, AN is that is methane. So when you have N to be 2, we put 2 into the formula, general molecular formula, we have C2H6, and that's our ethane. Then we look at N is 3, that is C3H8, that's propane. N is 4, C4H10, that's butane. N is 5, that is C5H12, that's pentane. N is 6 will be hexane, C6H14. N is 7 will be C7H16, that is octane, and so on. So I believe we get that. So now let's see some questions on what we have considered so far. Let's see. Number 1, the ability of carbon to form linkages with itself. Like the ability of carbon to form a straight chain, a branch chain, and a ring structure is called what? Combustion, catenation, sublimation, and carbonation. What will be the answer? Yeah, that's B, correct. So to be catenation, we made mention of that. Remember, it's one of the reasons why carbon has a lot of compounds. Number two, organic chemistry is a chemistry of dash compounds: nitrogen compounds, oxygen compounds, sulfur compounds, carbon compounds. Yeah, that would be carbon compounds. Correct. Option D, correct. The dash determines the chemical properties of a homologous series. The functional group, the formula, the structure, the none. So that will be the functional group, correct? Which of the following is the functional group for the alkanol? Carbon-carbon double bond, CHO, OH, COOH. That will be what? OH for the alkanol, correct. The third member of the alkane family will be what? The propene, the butane, the propane, hexane. Being the third member of the alkane family, we are going to have three carbon atoms. So if you have three carbon atoms, remember the prefix for three carbon atom is prop. Then it's an alkane family, so we join the prop with the A, so that will become what? Propane. That's option C. So propane is the third member of the alkane family. So I believe you understand. So yeah, we're going to stop here for today. But let's quickly review what we have done. So far, we have looked at compounds or substances that are organic. We have looked at what organic chemistry is. We have defined organic chemistry to be the chemistry of compounds that contain carbon. We talk about homologous series, which represent the family of organic compounds. We made mention of their characteristics. And also we look at the functional group that we use to identify organic compounds. Then we look at introduction to IUPAC nomenclature, where we consider the naming of alkane. So see you next class. Thank you.